For the last video here, I just want to talk about ionic radius in terms of anions, so the negatives. So I've got oxygen and fluorine who are going to be two anions. So fluorine is going to be able to take one, maybe. Give me a little electron, take it in. So notice down here before I do this, the atomic radius is 42 picometers. The ionic radius, oops, did it take it? Come here, bud. The ionic radius, when you take in that electron, goes up to 133. So taking in one, we were able to increase our ionic radius quite a bit. Well, oxygen can take two. So I'm going to put one in. So it's right now 48, and it needs one more to be stable. And notice it goes up to 140. So as we'd mentioned, the more you take in, the bigger you're going to be. The more you give away, the smaller you're going to be. So your anions increase in ionic radius size, as you can tell, the more they took in. So remember, the oxygen took in 2, the fluorine took 1, and we can definitely see that the one that didn't take in as much is smaller versus the one that took in more, okay? And remember, the cations were the opposite. The other thing that I want to show you with this simulation doesn't talk about electronegativity. It talks about electron affinity, which we didn't talk about. It's very similar. Electronegativity is the ability to attract electrons. So as we come to the right, you have a greater ability to attract electrons. Remember, that stops at the halogens, because even if I click on helium, even though you don't know what electron affinity is, I'll do this, okay? As you look at the noble gas one, you notice that it tells you it doesn't have this ability to pull in the electrons. It doesn't have an affinity for them because family 18 is full. They've reached their octet, and in the case of helium, it only needed 2 for that S sublevel. So these guys aren't going to be wanting electrons. They're not going to be pulling them in. They're not going to have the strength to pull them in. So remember, your electronegativity gets stronger as you go to the right. Okay, and it also gets stronger as you go up because fluorine is much closer to the nucleus than somebody who's down here. That gives it a greater ability to pull in electrons. So ionization energy is the amount of energy required to remove an electron from the gaseous atom. It becomes greater as you go across and as you go up. So helium is going to have the highest ionization energy. Electronegativity is the ability to attract electrons. So it increases as you go this way. As they get closer to that full octet, it stops in family 17 at the halogens. The noble gases are not going to have any desire to attract electrons. Remember, electronegativity also goes up as you go up on the table because they're closer to the nucleus. The atomic radius is the one that goes backwards. So as you go to the left, you have a larger radius, and as you go down, you have a larger radius because they're further away from the nucleus as you go down here. Ionic radius, just remember that give more, you're going to be smaller, take more, you're going to be bigger.